this will be chapter 3. Chapter 3, we're now segueing into topics about the file system, specifically permissions and ownership, which can be bundled up into what's called access control. However, it's really complementary with the previous chapter, because the previous chapter was about users and identity, and it is users that we grant or deny permissions to. So in terms of troubleshooting, which you want to be familiar with for your certification exam, there could be a problem with the configuration of a file, or there could be a problem with the user's configuration. All they know is things don't work. So it's the other half of the same coin. Users on the system, groups on the system, they want to access files and directories. This is what decides whether they can access them or not, what's called access control. So we'll talk about what the various permissions are that are out there on files and directories. It's actually a very simple set of permissions. We'll talk about the idea of ownership, and can that be changed? Can files be given to someone else? There's also a few specialized permissions. Most users don't come across changing them, but us as the admins, we do have to understand them. Some interesting ones there that make it easy for sharing or for elevated privilege, or some special attributes out there that could even deny the root user. But at the end, you want to be able to practice troubleshooting so that you can see what would cause a particular type of denial. So permissions are called access rights, and they are assigned to a user or assigned to a group, and they decide what you can do. If you do not have the access right, therefore you are denied. So we can set them, it says, at different levels. We're talking about the file system here, so I could set different permissions for the directories or for the files below those directories. But the idea is we want to follow once more the principle of least privilege. It would never be the right idea to simply grant all access to all users and groups. What we want to do is to dole out the minimum permissions for them to get their job done. But they have to get their job done as well. When it comes down to permissions, there are only 3 basic permissions called read, write, and execute. And if we think about what these permissions would mean, if I want to read a file, that would be to cat it. If I want to write a file, that would be to change it. For example, if I VI'd the file. If I want to execute a file, that means I want to run it. So commands like ls are executable. So read, write, and execute, fairly straightforward to understand with a file. The same permissions are also applied to directories. So I would need read permission to do an ls to list a directory. Now, execute on a directory is kind of a funny concept. If you replace the word execute with the word use, that makes it more understandable. How do you use a directory? Well, you could cd to it, right? I could access it. I could go down below it and find subdirectories and files below. That's how you use a directory. So I would need the execute permission to do that. But the one that's most important is the writing of a directory. And this is a bit different. The ability to create or remove files below a directory has nothing to do with write permission on those individual files. It is all controlled by the permissions on the parent directory. So there can be files you cannot either read nor write, but you can delete them. So we have to look at each level of the directory structure, files, subdirectories, and pure directories. And each level will have read, write, and execute. And these 3 permissions will be allocated to 3 categories of users or context called user, group, and other. There's a third one, which is the letter A, which means all. So with 3 permissions and 3 context, winds up being a total of 9 permissions. There are 9 permissions that are controlled in the metadata of each individual file and directory. And we're actually viewing all that when we do ls-l. We're looking at the 9 permissions. Here is a blow-up of ls-l, and you're looking at the leftmost 10 characters. When you look at the leftmost 10, the one to the leftmost has nothing to do with permissions. This is a single letter that tells you what type of an object it is. This particular object is D for directory. The next 3 letters are the context for the user or owner of the file. As you can see, the letters indicate that access has been granted. The user has RW and X. The second set of context is for the group. Who's in that group? You'll see they were granted only read and execute, but the group members do not have W. The last set of permissions are applied to the category we refer to as other. You should not confuse other with all. Other means everyone who is not in the group or who is not the owner. Again, I have access to the same 3 permissions. The dash indicates that W was not granted. They were granted read and execute. And they were granted that on this object called dir A. So every file and directory has this combination of 9 permissions, and some of them are turned on and some of them are turned off. Rarely would it be the right answer to turn them all on or to turn them all off. Now, the command we use to modify the permissions, I will pronounce changed, though some might call it chmod. Change the mode. In the old Unix days, the permissions were referred to as the mode. So we're allowed to change the mode, or say change the permission of a file. This can only be done by the owner of the file or the root user. So be aware as we go through this series of allow and deny, in general, just so you know, that this business of denying root permission, that does not apply to sysadmin. The root user does not go through discretionary access control. They have all the permissions all the time. This applies to any other user, a service user or a normal user. So I'm not going to make a point of saying accept the root user every time. I'll mention that when it's different. The root user can always change, and the root user can always go right through them. And when you do change mod, a couple of different options that you would want to use. Mostly, I would say use the V for verbose if you needed some diagnostics. There is an R for recursive, but you're going to find that typically you would set different directory permissions from the file permissions down below. For example, you'll typically make a directory executable, but you wouldn't necessarily make the files executable. So recursive, meaning set exactly the same permissions all the way down the tree, is not done as commonly as you might think, unless it's a big giant recursive disable. So when we do the change mod, we're going to have to use one of 2 notations. One notation here is what's called the symbolic mode. When I do change mod in symbolic mode, I'll have to have, first of all, a context, like maybe for the user. Then I would have to have an operation, like maybe add, followed by the name of the permission to add, perhaps read. Then I'll give that on a particular file. So I'm going very granular here, and I'm adding one single permission for one user account. But I could go a bit longer, and I could say, let's do a change mod. And I can say things for group and other, let's remove R and W on something like directory 1. So I can have actually multiple contexts there on the left and multiple permissions on the right. The thing that has to be a singular, to have only one of them, is the actual operator itself. Plus or minus means increase or decrease. The Equal sign means assignment. It means make it exactly equal to this. So we're using there the letters G, O, and U to indicate what context. Then, of course, the letters R, W, and X to indicate the permissions. So there's some quick examples where the root user is changing files that could be owned by someone else, by perhaps granting, right, to the group read, or for other taking away, or maybe doing a combination for group and other add RW. Now, I always believe for beginners, you'll always want to come back and confirm this with ls-l and verify the permissions came out properly for you. Once you've become seasoned, you'll feel confident without having to go back and confirm. That's what's known as symbolic notation. The other notation is even shorter, but it uses numbers. But the numbers are not too scary. They only go as high as 7. And they're a little closer to what's stored inside the file metadata, where everything is really stored as bits, or really stored in binary. So the number 4 is mapped to read permission. The number 2 is mapped to write. And the number 1 is mapped to execute. So as you can see, all 3 of them add up to 7. 7 would mean all of them. 0 would mean none of them. So what we need to do is construct one of these digits for each user group or context. In other words, it takes a 3-digit number to describe all 3 contexts. So there we have 764. That would mean read, write, and execute for the user, read, write for the group, and then read for other. Or maybe here, 640, that's read, write for the user, read for the group, and then nothing for other. So it's always a blanket or absolute assignment of all 3 sets of permissions to all 3 contexts every time you use the numeric. Versus the other style symbolic, we can say plus or minus and just turn one of them up or down as necessary. This one changes all the permissions all the time. However, experts get used to it. They just tend to gravitate to the numbers. So you'd eventually want to get pretty good at these numbers before you take your exam. Now, when files and directories are first created, they have a starting set of permissions. ChangeMod is only applied for things that are already existing. So the starting permissions are defined by what's known as the UMask. The UMask is an octal value very similar to the permissions that we described. What's different about the UMask is you don't specify the permissions that are granted by default on creation. Rather, since it's a mask, it is the permissions that are denied. So if I did ChangeMod 777 on a file, that enables all permissions on that file. But if I said UMask 777, that would mean any files or directories that get created, I would withhold all the permissions. The permissions come out as zeros. So the numbers are used inversely from ChangeMod. They're not the ones you get. They're the ones that you don't get. They're the mask or opposite of them. So the UMask is specified, as you can imagine, before things are created. So therefore, it's a great candidate to set in a login script. And of course, if you look at the last bullet point here, you can see that's commonly done. You can set it in your own .bash RC, or of course, there's a system-wide that is originally set up. And the system-wide one you can get by just typing in UMask all by itself. The system-wide one is 0022. And you can see there the definition of what it means to withhold the 2. When I withhold the rightmost 2, that means W for others. And if it's the second from the rightmost two, that means withhold W for group. Right? So those are the ones that are not granted when something gets created. And how do things get created? Make dir, touch, copy. All these are different ways to create files and directories. With the UMask, we specify what permissions are not granted by default. They can always come back and be tightened or loosened as necessarily with a change mod. So the UMask is really part of the environment. It's not really stored on a file system. It is created in part of the memory of the shell, and it's created by way of login scripts, much like an alias is part of the memory of the shell, but yet it's set up by a series of login scripts. So sure enough, the ETC, the system-wide login scripts, or your own personal scripts can set the original UMask, but if you have a command line, you can set it up yourself. So you can set one up for a particular session, or if you're writing a shell script for any files or directories created by way of the shell script. Let's take a look at the virtual machine. You can change some existing permissions and set up a UMask. Well, I'm logged into my shell now, and I have my current identity established. I am student 1 with my base credentials. And if I look at the files in my current directory, each of them has existing permissions. Every file has existing permissions. So does every directory. So as an example, this file here, called my_dmessage, only I could read or write that file. Any other user could only read it. Well, what I can do is I can modify those permissions since it is a file that I own. So here I can just say change mod, and I might say, well, for the user, remove read permission on the file called my_dmessage. Come back and verify with ls-l, and the only thing that was removed was the R permission. So now I have a very strange configuration here, which means the group and other, they can read the file, but I can't. I can only write the file. So that was a purposely constructed strange example. Don't want anyone to think that just because you have W, that implies you have R. Those are separate, discrete permissions. So I can change that file, for example, copy over it or edit it, but I can't actually read it. So let's go ahead and remove the other permissions of the file. This time we'll say, well, how about this for group and other? We'll remove read on my_dmessage, and we'll come back with another change mod, and we'll say, all right, for the user, we're going to add the read permission back. So now we'll come back and look at the permissions, and sure enough, now I have R and W, and now no one else had read and write. Now, how was it that the file created a little earlier, in an earlier chapter, wound up with read for user and group, but or rather for group and other, but no one else? That's because of the UMask. When I issue UMask, that tells me what permissions are going to be withheld. There, we would withhold permission W. When I create a file or directory, we'll withhold permission W from other. So what I'll do is I'll create a directory. I'll say make dir tempdir. We go back and look at the existing permissions that are out there, and sure enough, when I look at tempdir, down here towards the end, the only thing that was withheld was permission write, also known as permission to, for other. Now, I can still come back and change mod and disable some of the other permissions if I want, or I can do change mod and enable others. All the UMask did was specify the starting. The starting, what is to be withheld. So on a make dir, it starts with 777. Now, let's take a look at the permissions here of var log d message, the original file we copied. Its permissions are something we could call 644. 644. But if I have a UMask of 2, that would say withhold write for other when you make a copy. Well, they were never going to get right. In other words, when you create things, you're never going to get a higher set of permissions. You would only get less. So let's modify the UMask to now deny read for other before we make a copy. As student, I can't change the permissions on that file, but I can change my UMask, and I can make my new UMask 0004. Then you come back and verify with just a UMask command. Now that would indicate when I create a file or directory, then withhold permission 4, which is read. So now if I copy var log d message and just copy it to a file called d, when I do my ls-l on the file called d, notice how we went here, right? It was 644, but we withheld that final 4. So sure enough, now it's 640. So we started with the original and then withheld based on the mask. Similarly, when I created a directory and I withheld permission 2, you can see directory started with 777, but then we withheld based on the mask. Let's do another make dir, and we'll call this one temp dir 2. This time it'll start with 777, but it will withhold 4 from the final position. Come back and check all the permissions. And sure enough, there's temp dir 2. And you can see there's the missing 4, the missing read right there. So change mod, adding or decreasing permissions for objects that are already there. UMask only for things to be created. And of course, the original mask is always set by way of login scripts, but by just using command line, you can simply change it to whatever you need, and that mask will persist so long as the shell continues to run. But if I log out or close this window, then I'm back to the original mask.